This text is a part of the Chemistry Resource Book, Unit 1, Line Spectra. In emission spectra, you have two energy levels. In this direction, our energy increase. And what happens is that in emission spectra, an electron fall from a high energy level to a low energy level. When the electron falls like this, it emits a photon, a packet of energy. The energy of this photon can be labeled as E photon. Now, this electron is falling from the high energy. Its initial position is the high energy level. So this is our initial or the initial energy. And it ends up in the low energy level. This is our final energy. In any calculation, if we are to calculate the change or the delta, you always do final minus initial. If you really think about this, energy of the photon is actually this energy difference between the initial and the final energy level. So this is our delta E. Now how do we calculate this delta E? It is the energy of the final minus the energy of the initial states. The initial energy state, since it is high energy, this has a large numerical value. It is a large number. And our final state, since it is a low energy level, it has a small numerical value. It's a small number. For example, you can compare 100 versus 10. So what happens if you subtract a large number from a small number? Our E final is a small number. Our E initial is a large number. Just like if you are doing a 10 minus 100. This will give you a minus 90. Now look at what sign we have. So for emission, the sign for delta E is always negative. Now I'm going to rearrange, do some little changes into this equation I have written. You know how to get the delta E. It is final minus initial. But now I'm going to put this negative sign just to indicate that we are writing all these for emission. You can write it like this, or if you want, you can write it like this, where you put the negative sign on the other side. So either way, they work. I'll just erase this part to remove the clutter in this area. And then let's look at the other part of this equation where negative delta E has been equal to this relationship. We know how to calculate energy of a photon. We can use E equals h nu relationship. Also, we know that speed is equal to nu lambda relationship. So nu is equal to c divided by lambda. By substituting this here, you get this relationship. When you look into this diagram, now you know that delta E is the energy of the photon. So we have the energy of the photon, which is also this delta E. Then what is this negative sign over here doing there? I have not shown a negative sign in this place, but you can see it here. So what is this negative sign doing? It's simply saying that we are doing all this for emission. So I can go ahead and put a negative sign here just to indicate it is emission. And then you can expand the other part like this. So in problem solving involved in this part, this negative sign does nothing mathematically. It is not a mathematical operation in this expression. It only tells you the energy is emitted or energy is released.